it's time to have a look at what we've been talking about. Underneath this blanket, we have the dLive. So let's have a look at it. You can see all those plans and all those feedbacks and all that sort of ideas. The console has a fantastic presence. It does feel like a special thing. It's similar to the consoles we've done in the past in terms of the layout is very familiar, but as you can see, it's much sort of grander size and bigger touch screens, much more sort of tactile and responsive looking. Yeah. And there's the finished result. So we're very, very pleased with it. You know, it's an amazing looking thing. There's different sizes. This is actually the largest sized console. It's called the S7000, and it's really great to see it all the way here in India so soon after the launch and the shipping. So later on, after we've gone through the slides, we can then get our hands on the mixer and see how it actually works, and I can show you some tricks and some techniques and some of the interfaces and things that are available on the mixer. But we'll go through some of the specifications for the mixer. So basically, we kind of looked at what iLive did and doubled it. So basically, if you think of an iLive, if you're not sure what it's got, double the number. So sampling, this is amazing. From a really good sounding 48K system now, we're now using 96K sampling. That's a first for Allen Heath. We've never done this before. That means we're now up in the market with the big sort of Digico, Studer, SSL type of end of the market in terms of sampling and sonic capability. We took a 64 mixing engine with 64 inputs. We're now doing 128 inputs as standard in every dLive system. 128 mic inputs. We doubled the number of mixes from 32 processing mix outputs to 64 output buses or processing mixes, all with full processing, believe me. It's fully stuffed. And we took the 8 effects and we've taken that system and doubled that, and so now you have 16 onboard rack effects as standard on the dLive system. The only thing we didn't do was double the price. You'd be pleased to know. It was very tempting, but we really tried hard to come in at a fantastic price for what you're going to get for the money. Yeah, we even gone to 2 screens on some models. So there's a small model which has 1 screen, but generally speaking, it's a 2-screen system and the bigger screens. And lots and lots of things have been upgraded and added to and improved in technology. So it's very exciting.
The kernel of the mixer is a new FPGA engine, which is capable of not just 64 into 32 mixes. This engine's hundreds of inputs into 64 mixes, and this implementation is 128 into 64 mixes, all at 96K sampling. That represents a times 4 on audio signal processing requirement. Couple that with the enhanced processing requirements for filtering, for more advanced compressors and dynamic EQ on channels in the future, that really adds up to a ×8 power factor on what iLive's capable of, and that required a lot of innovative work in FPGA to provide that platform. You can't do this with traditional DSP. We ported the iLive algorithms and also provided more facilities to develop much more powerful algorithms in the FPGA. To do that, we had to develop DSP kernels in FPGA that were capable of running those algorithms, so they really appear as mini DSPs, but much more powerful. We had to also study the bit widths and the bit widths and the way we wrote algorithms on DSP and try and reproduce that in FPGA. And in fact, we've ended up with much wider bit performance where it matters on FPGA when we enable DSP?
Well, one of the main limitations on the DSP side was that with the high level of I/O, you know, the 128 inputs, the I/O on the actual DSP chip just wasn't there for a start, and that's not even taking into account going to 96K. You've obviously got a fixed number of cycles in your DSP, so you need twice as many of them, and those are consequential problems from that. So to move into the FPGA was kind of the obvious choice, I suppose. To get the mixer going was brilliant, and then we thought, right, how can we go from use this kind of methodology to generate something that would do all the audio processing, implement the same kind of algorithms we wanted to maintain from dLive and the GLD.
To get the sonic performance right and the way the controls change and filter types change, it's very important to look at bit widths in all parts of the algorithms. And we've done that with FPGA. We've taken the same knowledge that we had on iLive, implemented on DSP, into the FPGA domain.
Yes, so FPGA is the new technology, something which our brother company Digico pioneered, I believe, in their mixing. And basically, the way I understand it, I'm not a rocket scientist, but I believe it's the DSP is an architecture, it's a third-party chip which is built as a processing chip with a number of inputs and outputs and technologies embedded in it. And if you need to do larger mixing tasks, you need to employ more and more DSP chips, which still are fixed in what they do. The way an FPGA works is it's almost written when you power the thing up. It's injected with code and becomes a mixing engine. It becomes a processing tool. It also can do whatever you want it to do in the future. It's not fixed in its architecture as a chip, which means in the future, as firmware changes, as demands change, as the market changes, the mixer can respond with firmware and different coding to do different jobs, and we can accelerate and add the processing power and the architecture where it's actually needed. So it's very, very exciting to have something which is a sort of fluid in engineering terms, very, very powerful and capable of grasping the future and being able to respond. So that's the FPGA technology. It has parallel sort of processing cores to give it all this way of computing the processing. Enough power to do 160, that's 128 inputs plus 16 effects returns, that's 16 times 2 stereo returns, which is 32, gives you 160 input channels mixing into 64 output processing channels to give you that kernel. As Rob said on the video, we've taken the iLive algorithms, the really good channel processing, the EQ, the dynamics, and the effects as well, in some cases, being now ported through to FPGA into the new technology. So an incredibly powerful processing engine there. You can see the router there. They're claiming it can do 3,000 by 3,000 audio paths. It needs to be capable of joining together and a very, very, very comprehensive architecture that can be created in there. Another thing that we've looked at when we've designed this mixer is something called mix coherency, which is the sort of time alignment of where signals lie when they're mixed to different parts of the mixer. You do get a lot of problems sometimes with digital mixing. For example, if you take an input channel and mix it straight to LR, and then you go take an input channel, the same channel, and mix it to a subgroup, and then mix that to LR, you sometimes then get problems with these things all arriving in the mix at slightly different times. This creates filtering and unwanted artifacts in the audio, makes the audio sound confusing, and there are ways around it, but the ways around it, and certainly in the most expensive digital mixes, will cost you overall system latency, because you have to use up latency and then add delays to certain parts of the mixing path, so everything becomes time